Watch this video in Lesson Reach. Pause and ask questions, take a quiz, or get help with assignments. Link below.
Every time you use a computer, it's doing like mind-bendingly complex math using only two numbers, just 0 and 1. Welcome to today's deep dive, where we're going to figure out how that is actually possible. And to make sense of it all, we're trying a unique setup today. I'm playing the eager student asking the questions, you're probably yelling at your speakers at home, and my co-host is sitting in the lecturer's seat.
Yeah, I'm taking my lecture duties very seriously today. Our source material for this session is section 4.4 of chapter 4 from Contemporary Mathematics. We're exploring how addition and subtraction work in non-traditional base systems.
Oh.
I know it sounds intimidating, but the secret is that it's exactly the same math you already know.
Okay, let's unpack this, because the textbook points out that computers use base 2 since their circuitry only recognizes high and low current, right?
Right, exactly, just on or off.
Yeah, so on or off, 0, 1. But if the mechanics of math don't change, how do you calculate anything complex without, the numbers 2 through 9?
Well, you do it by building a completely new addition table based on your available symbols.
Yeah.
Let's look at the base 6 example in section 4.4.
Okay, base 6.
Yeah, so in our normal base 10, we have 10 symbols, 0 through 9. But in base 6, you only have 6 symbols, meaning the largest legal digit you can actually write down is a 5.
Wait, if 5 is the absolute limit, what happens when you add 5 plus 1? I mean, the symbol for 6 literally doesn't exist in this system.
Exactly. This is where the text introduces the jump method on a number board. But let's think about the actual mechanism of why that jump happens.
Okay, lay it on me.
When you add 5 plus 1 in base 6, your column gets completely full. You've basically run out of symbols. So you have to bag those units up, carry the 1 over to the next place value column, and leave 0 behind. You land on 1, 0.
Ah, right. So we don't say 10 out loud because it's not 10 items. It's read as 1, 0.
Right, meaning 1 group of 6 and 0 single units left over.
Which means if I do 5 plus 2, I don't need a math degree to guess. Do we just jump one more space? It rolls over to 1, 1.
You got it.
Here's where it gets really interesting, though. It's exactly like our normal math, but the rollover where you carry the 1 just happens a lot sooner.
It does, yeah. You were just hitting that rollover point at 5 instead of 9. But because human brains are so deeply hardwired for base 10, it's incredibly easy to make mistakes.
Oh, I bet.
Yeah, the text actually highlights 2 common errors when working in these new systems. The first is using an illegal symbol, like writing a 9 in a base 7 problem.
So making that first error is basically like trying to play a word in Scrabble using letters that aren't even in the game.
That is a great way to put it, yeah.
Like if you're in base 7, your rack only has tiles 0 through 6. If a 9 shows up on the board, you know someone is breaking the rules.
Exactly. And the second error is your own muscle memory betraying you by accidentally applying base 10 rules.
How does that happen?
Well, say you're working in base 13. Your brain sees 9 plus 9 and automatically wants to jump to 18.
But 18 assumes we roll over after 9. In base 13, you haven't even hit the rollover point for a single column yet.
Precisely. You have to physically consult your base 13 addition table and count the jumps properly to find the real answer. Math is really just a universal system of rules.
Yeah, that makes so much sense.
Whether you're a computer processing 2 states of electrical current or a human counting on 10 fingers, the underlying logic of place values and carrying the 1 is totally identical. Once you know your legal symbols, you can build an addition table for absolutely any base.
Which completely demystifies that computer doing base 2 math. It's not doing alien arithmetic, it's just rolling over to a new place value extremely fast because it only has 0 and 1 to work with.
Exactly. We only think base 10 is the normal way to do math because we were born with 10 fingers. If we were born with cartoon hands, we'd all be doing math in base 8 right now. Base 10 would feel weird.
That is a little unsettling, but completely accurate. But before we wrap up, I want to leave you with a final thought based on the exercises in section 4.4.
Oh, the letter ones.
Yes. The textbook mentions base 12 and base 16. Because those bases need more than 10 symbols before their columns fill up and roll over, they actually use letters A through F as numbers.
It's wild to think about.
It really is. Try to imagine how your brain would have to shift to carry the 1 when you are adding actual letters together. Just something to chew on next time you look at your calculator. Thanks for joining us on this deep dive. We will see you next time.